Myself, I am Dr. Jntuh. In this class, I am going to discuss with the process concept. These are all the contents which we are going to discuss now. Process concept, process scheduling, various operation on process, inter-process communication, communication between the client and the server, and various multi-threaded concept. Before moving to the topic, we should know what is a process. A process is nothing but a program that is going to be executed in a regular manner. It contains both the program code and its current activity. An operating system is capable of executing various types of programs, such as batch system that is going to be executed in jobs, and time shared system user program that is capable of performing various tasks at a single time. The process memory is divided into 4 sections. The program code entered here is otherwise called as a text section. In this, we are having 4 different types of section. One is program counter, stack, heap, and data section. Program counter is nothing but where we can store the millions of contents of process register in that. Stack is a temporary memory unit. It can store different types of function parameters, local variables, return address, like that we can store in a stack. Heap is a dynamic data memory. It is dynamically allocated during the program execution and its runtime is executed as its variably in a similar form. Data section, which will contains the global variable. So this can be explained with the help of this diagram. So these are the 4 processes in a unit: stack, heap, data, and the text. As we know that program is a passive entity, it can capable of store the value on a disk in an executable file. A process is an active entity where the program is going to be execute the next instruction in an associated manner. The 2 common techniques of the files are execution of a program by using GUI features and another by using the concurrent mechanism. The next topic is process state. As we know that the process is going to change its state each and every time during the current activity of a process. A process may be of following state: new, running, wait, ready, and terminated state. The new is a process which is going to be newly created is called as a new. Running, the instruction which are going to be executed in a correct manner. The waiting, the process is waiting for some of the event that is to be occurred. For example, we can say that input event, output event, or the completion of a signal. Ready event, the process is going to be in a waiting state, which is to be assigned to the processor. Termination state, the process has finished its execution successfully and return to the main function. This is called as a process state. So this can be explained with the help of this diagram. So this is a new state which is going to be admitted into the second state that is called as ready state. If the ready state is free without any interruption, it can capable of move to the next state that is called as running state. If it is wait for the input and output operation to be completed, it will move to the waiting state. Here, the scheduler will dispatch which the input event is to be given to the particular ready state, and it is being interrupted by the running state, and the scheduler is dispatching the particular input and output event to the running state. After the running state, it will move to the exit state that is called as termination state. Here, the process is going to be end in a consecutive manner. The next topic is process control block. The process control block here, each process in an operating system will be represented in the PCP block. It is otherwise called as a task control block. Here, there are different types of process control block: process number, process state, process counter, CPU register, CPU scheduling, memory management information, accounting information, input and output station, after the list of opening of file. What is a process number? Process number is nothing but showing a unique ID or a unique number of a process. Process state is nothing but a running and waiting state of a process. Program counter will locate how many number of instructions are going to be executed in the next state. CPU registers will store all the contents of the process in a centric manner. CPU scheduling will allocate the priority basis scheduling in which are waiting in the queue pointers. Memory management is a technique where the memory is dynamically allocated to the particular process. In the accounting information, the CPU is going to be scheduled the start and stop limit of the particular sequence. In the input and output status information, the input and output devices allocate the process and list the files of opens here. This is how a CPU is going to be switched from one process to the other process. Here in the process 0, the process is going to be executed. It is going to save in the PCP block. Whenever the interrupt is occur or a system is being to be called, it will went to the first save state, or else it will move to the reload state. In this condition, the system will become remains ideal and it will execute. After that, it will move to the next block. So the next block is also in the same condition. If the interrupt is not occurs in the particular state, it will save the particular location and move to the next process that is called as process 1. This is how a CPU is going to switch a process from one end to other end. Moving to the next topic, that is thread. A thread is nothing but a unit of execution of a program within a process. A process can have different number of threads. Process is a program that performs a single thread of execution where it performs more than one task at a time. The thread is usually a beneficiary on the multi-core processor and it is run parallelly. It is the most advantage of a thread. Difference between the process and a thread. Process is nothing but we can execute in a program. Thread means a segment of a process which is going to be run. Normally, the process is not a lightweight process. Thread is a lightweight process. The process can take more than one time to terminate after the execution of a program. It will take a long time to execute the particular process. The thread will take very less time to terminate the process. The process will create more time for creation of a new process. Thread will create only the less time while the creation of a new process. The communication that takes place between a process will need a time that is compared to the between the thread. The communication between the thread will require a very less time compared to the process. The context switching in the process is very more time compared to the threading time. The process will consume more number of resources. Thread will consume fewer number of resources. It is differently operated and it is separated by the OS process, and the thread is not separated by the OS process. The process is usually a isolated one. Threads will use a shared memory object. It does not have any different type of shared data. Threads share the data with each other. Thank you.